So we're so lucky to have with us today Erika and Luke from Redivivus. This is a new company. We've talked to them a little bit before, but I think this is the first time, Jesse, that we've brought them to our whole channel.
Yeah. I mean, I think for anyone who hasn't met these two lovely people, you're in for a treat today.
Yeah. So we're talking about battery recycling, and this is a small startup company that is doing just that. So thank you, Erika and Luke, for being with us today.
Thank you for having us.
We're really excited to be here. Thank you so much.
So Erika Guerrero, she's the CEO, and Luke Workman, of course, has the best title ever. He's the chief battery scientist. And we're going to learn a little bit more about their company today. I just want a disclaimer at the beginning of the show. I just invested in Redivivus, and we're going to tell you later in the show how you can do that too if you want to, if it hasn't already closed. So we're going to get into that and ask some questions that our investor club members have already asked. So we kind of know like what you're interested in finding out about this company. So let's just dive in and see what we can find out about Redivivus and battery recycling. So one thing I want to remind everyone at the beginning here, not all small companies make it to become big companies, but all big companies that we know of today were once small companies. And this is a small startup. We talk about this a lot on our Now You Know Investing member part of Patreon, but you can actually invest in some of these small companies. And that's, to me, the exciting part. You can put your money where your mouth is when it comes to our EV revolution. And so, guys, tell me what you guys are working on right now at Redivivus.
Well, we have many projects right now to streamline cost minimization, chemical reagent minimization, and always looking for ways to reduce process time and wear on equipment, especially shredding and processing equipment as well.
In the recycling industry, we noticed that there was two major problems. One was the logistics and the passivation of the battery material. So where do you pick it up? How do you make sure that it's safe? And then the second is the reclamation. And so normally when people are talking about recycling, they're talking about the reclamation. And it's really good to distinguish those two parts, because even though it's all one industry, it really is two major roles, where we noticed that there was a lot of companies that were not really looking at how do we get these batteries to a state where we can recycle them.
So, but I mean, what's the problem? Like, we have recycling trucks, right? So, I leave my recycling out for the recycling truck, and they come with their thing, and it picks it up and it dumps it in. Yep. Well, let's do that with batteries. That seems like it works, right?
Sometimes batteries do make it into garbage trucks, and that's often when there's fires in garbage trucks or fires at the garbage dumps. I saw some statistic that from some particular dump that said like over half of all the fires they had were from people throwing away lithium-ion batteries. But more importantly, let's say that it's not a small consumer lithium-ion battery. Let's say it's a large electric vehicle battery. Suddenly it's a safety hazard if in the event that you're transporting it and there's a problem, and suddenly there may not even be a practically feasible amount of PPE that you could provide to transport them safely, depending on the condition. Some people get in wrecks right after they got off the charger at a full state of charge, and the wreck causes damage that disables the normal discharge means for this battery system. Now, it's a multi-stage process. We have to make it inert to be safe to shred, and then after shredding, then the shreds, if they warm up, can be a hazard, and so the shreds go straight into an aqueous buffering solution to neutralize the chemical potential energy stored in them so that they don't have that risk of fire afterwards.
To answer it simply, Redivivus is working on a cost-effective, environmentally friendly way to pick up batteries, neutralize them, and recycle them.
I hadn't really been thinking about neutralizing the lithium-ion batteries, because we're so used to having, at least in this house, we're so used to having them around. They're in tools. Obviously, they're out in the driveway.
They're on our set.
Yeah, they're on our set. I have some in my pockets, in my phone. I don't just carry around 18650s most of the time. So you're saying that it's a problem to actually even just pick up lithium-ion batteries. Now, my question is, when I go to the store, some hardware stores and stuff, they have a cardboard box, and that's where I'm supposed to put my batteries. How can I be putting them in a cardboard box if they could be blowing up?
Well, usually they say something like you're supposed to tape the terminals and put them in there discharged if you're able to put them in there discharged. And in those conditions, if they're taped from shorting, it's significantly safer. The trouble that you get into is, let's say that you have EV packs that have something abnormal, whether it's flood damage, whether it's crash damage, whatever this issue is, even manufacturer errors. But if you have this problem, you don't know that while you're shipping this assembly that problem doesn't become worse. There's not a proper nerfing procedure for each battery pack in each kind of crash damage condition, and I don't think that it's feasible to create one either. It would be a very wide range of different types of damage and different types of potential fire hazards, some latent hazards like the corrosion-induced salt bridging related hazards. These could be really difficult to spot for anyone until a moment before they become molten and smolder and start a fire.
I think it's a lot different when we're talking about batteries that you go drop off in the cardboard box versus large batteries like electric vehicles and larger than that. What Redivivus is really focusing on is that there are the possibility to have these giant recycling centers, right? So those cardboard boxes basically get shipped off in the right packaging to a recycling facility where they have some sort of neutralization effort. The issue with when you're talking about like e-bikes and you're talking about light electric vehicles, big even aircraft vehicles, we've been working on some batteries for really large applications, is that it costs so much to ship those because they're effectively classified as DDR or material that is really hazardous to ship. And so let's say you pay $100 for a battery because you import it from Asia and now you resell it. It's actually going to cost you at least that much to recycle it, which really makes it not effective it's not cost driven for companies to do it in a way other than just kind of shipping it off into the unknown.
Well, that brings up kind of a good point, because the more research I've done into recycling, the more I've found that a lot of recyclers just throw them away or burn them. And so I think us as consumers feel good when we drop them off somewhere and we're like, I did my part. But they're not really getting recycled a whole lot of times. Is that something you've heard too?
Yep. Unfortunately, a lot of the places that they end up is on barges that go to areas in China where they're incinerated. And the ash that's left after they incinerate them is what's recycled. And so they're not entirely not recycled, but it's almost a universal process, but also a universally dirty process.
I would argue that it's actually better for them to be burned than it is to be put into a landfill, because you do have the ability to reclaim some of the materials from that. But overall, burning trash isn't a sustainable solution.
The cost to scrub these things shouldn't be underappreciated either. If you want to try to do this type of process in a clean fashion, it's a surprising amount of water you go through and a surprising amount of scrubber filtration and neutralization materials you go through.
So that kind of leads me to my next question, which is, in the plastics world, a lot of us think that we're doing the right thing by putting the plastics into the plastic recycle bin, and it turns out that those aren't being recycled either, that only a small percentage are. So in this battery world, is it just because it's not cost effective to recycle them? Like, why are you guys trying to do this if it's not that cost effective?
That's a really good question. I think that the first reason why we got into battery recycling was 1, human safety, and 2, environmental. And I want to talk a little bit about our partners and how Redivivus kind of came to be in a way that was more creative than we could have ever thought of to develop a cost-effective solution. Redivivus really came to be because we knew that we needed to use our niche skills to help the industry basically stop burning or stop using a lot of solvents and reagents. And I'm not going to ever turn away government money, but at the same time, we wanted to develop a process that didn't have to use government subsidies. And so we were talking to different recyclers, and essentially the main rhetoric we got back was, we need to discharge all the batteries before they can be disassembled and shredded. And from Luke and I's forensics experience working at our R&D facility, we know that it's really not possible to discharge batteries at a large scale effectively to scale up a recycling process for the amount that we needed. So it really was getting with our partners. One of them, his name is Alex, and he's a metal expert. So he worked at Ford for a long time. He worked on new generation steels, things like that. Another one is Evan. He's super smart. He's our VP of engineering. He's worked in mining and chemical plants and initiating those for a long time. We also have our CFO and business manager, Erika, and he works to just make sure he runs all of our financial models. So he's kind of like the financial sanity check to our research and development. And then we also have Eric Fleming, who has been such a huge part in getting this investment rounds going and really making those industry connections. He helped brought up the supply chain at Tesla and SpaceX, and they really are super into metals, as you may have seen in your research. And that ability to have those connections allowed us to think outside the box with recycling and address some of the main concerns to create products into secondary markets that allow us to be cost effective and drive people to say, hey, I can reuse these in a secondary application.
In the plastics world, it seems to still be cheaper for people to go get virgin materials. Rather than using recycled plastic. In the battery world, I imagine that we just haven't begun harvesting many of these materials yet. And so that's probably why we're just going to get virgin materials. But can you imagine a world in maybe a few years where it's actually better to go get the materials from recycled batteries?
I just wanted to comment with respect to the plastics situation. If you had a known, clean, and common polymer thermoplastic feedstock, recycling it wouldn't be so bad. And in fact, you see people turn things like milk jugs into wood replacement for house deck planking and things, However, the challenge is that if you get some aspects of it wrong in sorting, you may add some plastics that melt or boil at a much lower temperature than the plastic you're trying to add, and so they blow bubbles or cause porosity or burn sections. Anyways, whatever the problem is, they are very fussy about contaminants in their ability to make a clean product. Let's say you want to make containers. If the containers have random pinholes in them from your impurities or your bubbles or your missed polymer contamination, then it's not very great for the container business. But anyways, that's why they have some niche applications like decking, where if you have pinholes in it, it doesn't matter. Normal wood had pinholes in it anyways.
I don't know too much about the plastic industry, but I do know from a few different mining workers that these mines are now super deep and super large. And these main veins on how these minerals are really taken out of the earth, I don't know how much there is left. So as far as if it's going to be easier to get secondary materials in the future, I imagine so, unless we all become alchemists and we learn how to change one element to another, which is super cool, futuristic idea to think about. But we need to make sure that we have a preparation plan.
And the amount of neutron radiation you need is pretty scary for transmuting elements too. But
So if we take the average EV battery, like the one in my Model X, when it reaches the end of life, and we recycle it, can you guys get any useful materials out of that?
oh yeah, a ton of, well, not a literal ton of nickel, but hundreds of pounds of nickel.
Wait, isn't that the material that Elon said he would do anything to get? Like, he's basically desperate for nickel?
He's begging mines to mine him nickel.
He is desperate for nickel, right? But he's desperate for nickel that has extremely low ppm of impurities that would affect battery performance.
There's a lot of different applications for nickel. And so it's kind of important, Luke, if you want to talk about like different ratios of chemistries in these lithium ion batteries, because they're going to vary from, like, if your Model X is from 2015 versus today, it'll have a very different ratio in it.
We found some fairly recent Model 3 cells are something like, they like to start with 8 in front still, but it would be 8.3 to 0.4 fraction cobalt, and then final a small fraction aluminum as well. But it would be like going beyond 16 to 1 ratio of nickel to cobalt in these cells, so very low cobalt in their cathodes. And so the neat thing though is a lot of electric vehicles were produced with ratios of 1:1:1 cobalt, so like equal fractions cobalt to nickel in their cathodes. And so our process works with these early batteries, in which case there's a significant amount additional metal value in those because of the cobalt, as well as modern batteries to extract mostly just nickel as the byproduct. But we of course get lithium as well and copper. We end up with aluminum and fluorine as well as, let's not say unwanted, but they're part of the process that we have to deal with in order to recover the highly profitable materials. And so it's just part of the process in completing the circle of the waste stream for batteries.
I also don't know Elon personally, so I'd be curious to hear his master plan on nickel specifically, because I know that there's definitely a few different applications on why he would want that.
Yep, Starship, Cybertruck. So stainless steel, for people who don't know, because it's just steel that doesn't rust. It is an alloy that has a lot of nickel in it. So if you want to make stainless steel, you're going to need some nickel to add to the iron and carbon and other stuff that you throw in there into the pot that you stir.
By the definition of a stainless, it's an alloy with a given percentage of chromium content, but the high performance stainless alloys use a high fraction nickel. And so I think what they would be launching into space is likely a high nickel fraction. And the beauty of using it in the structural applications is, let's say that you're 25 parts per million copper in your nickel, for use in a structural stainless application, especially as an additive in a stainless steel where the dominant ingredient will be iron, then this 25 ppm copper is further cut by the dilution of iron, and so you end up with not having the same constraints that a battery grade alloy would require in purity, where it's not going to be cut and diluted to form some larger batch. It's just oxides of nickel, cobalt, aluminum, or manganese, depending on the ratio or cathode material.
Now, one of the things that excited me as an investor about this business of recycling batteries is that I believe there's an EV revolution taking place as we speak. And so I pictured going out 5 years, 10 years, 20 years, and I pictured that basically all cars on Earth, all trucks on Earth, all buses on Earth would be powered by batteries. And then I thought, okay, well, if that's the world I live in, then there's got to be recycling of these batteries. And so then I was like, so I should be looking into investing in recycling companies. Tell me what your world looks like. Do you think that I'm on the right track here? Is that why you're going into this business?
I would love to think that you're on the right track. I mean, every day when we look out, we see more electric vehicles on the road because we live in Southern California, and that's pretty amazing to see.
Yep.
But we're definitely in a bubble for sure. I know that there's a lot of lobbyists, and you see it in a lot of campaigns out there today, kind of like closing nuclear plants, pushing for more coal, pushing for more dirty energy to power our cities. We're definitely in a revolution, and we definitely need to just make sure that we're all using our critical thinking skills to think about the future that we really want and not act in fear.
I see a beautiful electric future. If you drive a Plaid Model S, for example, everybody that we give a ride to, they're done with internal combustion at the end of the ride. You go like around one city block lap in a Plaid, and it's over for them. Like the love affair or the interest or whatever it was is dispelled, and they welcome the electric future, not grudgingly, but thrilled and with open arms for more vehicles like the Plaid.
To answer your question on why we got into battery recycling, we got into battery recycling, one, because at the front end of research and development in the battery industry, we're able to work with cell suppliers and pack integrators and interconnectors that are able to create batteries that last decades. And that's going to be a really big part of using the materials that you've gotten to that purity, that you've spent all that energy to get those battery cells and those batteries together. To last its real life. Well, cells are amazing. The manufacturers are amazing. They're accuracy and their quality is really amazing.
Yep.
What we're really seeing is starting to see failures, and when it starts to get into the integration stage, which is very normal. And eliminating those is going to help you where you say, I bought a Model X in 2021 and I'm still driving it in 2071. I would just love to see that. But as far as, reusing those materials, I do think, as more people come onto the planet and as we become a space-bearing civilization and we need those stainless steels, those super alloys, there is going to be a high demand for these materials. And we basically saw an opportunity where we personally know where there's just like piles of one man's trash is another man's treasure. And we were like, let's get this treasure and let's help the planet in doing so.
Now, as an investor, I like to know what the C-level suite, what their experience is. And I was really impressed to look at your background. So, Erika, you've worked before at Borg Warner, Romeo Power. You even worked, I see, on the Dragon 1 capsule at SpaceX?
I did. Yeah, I actually studied sociology, and I was always been into physics, but even more into how do scientists break into new paradigms and change the world. And through that, I actually was working on implementing supplier diversity into the Dragon 1 program, where basically we just had to make sure we followed the NASA contract and we were buying from the right suppliers. And that really kind of opened up my eyes to how many different people and types of people are really interested in doing great things.
And then, Luke, you worked as a critical environment engineer at Microsoft. You were a battery specialist at Zero Motorcycles?
Yep. After doing data center batteries and rotary UPS and data center cooling, I left following my heart and passion for electric vehicles and motorcycles to Zero Motorcycles, who had recruited me. And it was very humbling and painful as an introduction to the real world of corrosion and vibration, because all the designs that I'd built in the data centers get bolted to a concrete floor in a temperature and humidity controlled environment. And so, it's this very special pampered situation where, provided that you follow acceptable cross-sectional area rules on bus bars and have good current density and joint integrity, your system will work, for the life of whatever the equipment can handle. But moving into motorcycles where people jump them 120 feet and then power wash them. Surf. Yeah, ride them in the ocean surf, power wash them, ride them on salty winter roads, and this was when I first got a wake-up call into what the real world does to vehicles. And this was 2011, 2012, 2013. Those were all really painful years of my life in learning all the ways, the creative failure mechanisms that batteries can have in abusive environments. But there was a light at the end of that tunnel, though, of a crazy amount of long days and trying every kind of solution I could think of and consulting the best experts in the world for every kind of solution they could think of. And eventually we figured some things out and stopped having failures from vibration completely, stopped having failures from corrosion completely. After perfecting those two huge obstacles that I'd spent so much of my life on, I realized it was time to help share these with the rest of the world so they could overcome these huge opportunities. And in partnering with Erika, it was hugely enabling to achieve our dreams and help so many clients now have world-class durability and robustness in their products as well.
That's where that story of us coming together at the forefront of R&D really happened. But once you help clients and share your knowledge on here's all the ways I've failed, and help them innovate to make even better products than what we've made, then they start to ask you the question of end of life. And when we didn't have the answer, I think our naturally curious minds went out there to take a look.
We went to different battery shows and some recycling shows, and we went to every single booth. We got the program for the event and looked up every single recycling booth, and we sought them out in a line one after another. And at the end of going through all of them, we realized we didn't know who to tell our clients to recycle with. And that was kind of we thought, wow, is there really this hole in the market? Is there really this opportunity? Is there this process that needs to be developed? And so started working on it. And
I've loved it. We've gotten to talk to so many cool people, like even talking about recycling equipment and chemistry and all the fun parts that come into recycling. It's just, if you think about just an emerging industry, just like the EV industry has been going for a long time, but now it's starting to become mainstream. This is something that I do see is going to become mainstream. One, because there's going to be a dire need for materials. But two, because I think it, just as you shared, Zac and Jesse, like you have the question in your mind on what happens to this at the end, right? Because we just crush all the ICE vehicles out there and leave them in a junkyard. Well, that doesn't really work out.
They get crushed and then their engines get ripped out and they hit them with something that breaks the aluminum off of their crankshaft and stuff, and they pull the steel out and then they melt the aluminum down and the steel crankshafts get melted down. They save all the catalytic converters out of the gas cars too these days. Back when I worked at a wrecking yard when I was in college a long time ago, they just crushed all of that. But today, if you go to a wrecking yard, they have huge piles of catalytic converters and things because those materials are so much more precious than they used to be 30 years ago. And I think we'll probably see the same thing with electric vehicle packs as well, where things that were thrown away or dismissed by recyclers or stockpiled by recyclers will, when cobalt and nickel are at the right price, it will look extremely appealing suddenly, like they're little pockets of rich ore veins to mine rather than a waste material.
We've even seen some cool projects of people that sweep the sides of highways and freeways because you're able to pick up what the catalytic converters basically shoot out. So it takes in something nasty and poops out some platinum.
And rhodium.
So this company that you made is really born from necessity, and they say that necessity is the mother of invention. So, I mean, you looked around. It's not like there were all these other companies with great battery recycling schemes. You couldn't answer some basic questions when it came to battery recycling. And was that mainly in what do you do with a battery? Like, because I mean, you just think, oh, I have a battery. It is now in my inventory. I bring it to the place and then I give it to them. But it isn't always that simple. If I'm on the side of the highway and I just smashed my Tesla into something and I don't know where the battery connector is, and the firefighters, maybe they cut that thing that, is in my frunk that says like, cut if danger. Okay, so maybe that's done. But like, then what happens? Does it get towed or is it a hazard to the world? And what do I do with it now?
Well, that's a complicated question. And each OEM works to try to make the safest system they can. Mid-string contactors, for example, where after the pack is deactivated, or even every time you key off and the contactor's open, it splits the string in some serious point. There's a handful of other tricks that you can do to try to help have active safeties or integrated safeties. Like pyro fuses, of course, that can blow on command if the vehicle was in a crash, are pretty slick too. There's lots of active applications, but there's also so many vehicles already shipped that don't have a lot of clever solutions, and I expect people will find more solutions as time progresses to make vehicles even safer after wrecks and safer for emergency responders as time goes on. But
there's already millions of EVs out there, and we don't know exactly. And especially when I get in the wreck, what am I going to be doing? Googling like 2018 Model 3, or like my Leaf, 2013 Leaf, how to safely ship after crash. What am I going to find?
There's a book for first responders. I only know about this because at Zero Motorcycles, I had to make the diagrams for the pages for when they respond to a Zero Motorcycles related crash. But there's cut points for where an emergency responder is supposed to snip to be safe to themselves and to try to neutralize the risk of injury from arc flash to EMTs or fire risk or shock risk.
In all reality, if there is a wreck on the road and an electric vehicle they are probably going to have to put it on a tow truck, and it may or may not catch fire on that tow truck to take it to a different place. But as far as, let's say, if you're in Massachusetts and the closest recycler is in Ohio, taking it those hundreds or thousands of miles to that recycling hub is a lot more dangerous than taking it, tens of miles or a few miles to your local yard. But even then, stockpiling that at a local yard, that's kind of where our vision came from of we need a way to make sure that on the road, we don't have hazardous materials being shipped. We've personally done a lot of battery testing, and I have felt the heat of plasma on my face, and just having a lot of that on a truck being shipped out. And regulators are doing a great job as far as classifying things and making sure that it's packed as best as possible for the least risk. But we really wanted to kind of just eliminate those risks.
Yep. Reducing risk is different than inert shreds where they're harmless at that point, which is a great state to be in from something that was otherwise dangerous in multiple ways, from arc flash to fire risk to shock hazard, dangerous in all those aspects.
And there's great technology out there, right? There's companies that have gotten millions of dollars of whether it's government funding, VC funding, they have a plan, right? We are a small company, but really from what we have seen out there is that even the small companies can have big ideas.
So, this is what really excited me about Redivivus and why I invested, was that you have a solution now that isn't really out there. And so please tell me about redi-cycle and redi-shred. How do those work?
I think it's really important that when I'm talking about this, I'm using forward-thinking statements. As I've grown into this company and we've done crowdfunding and whatnot, we've done a lot of great work. But right now we're really in a time where we're developing our technology to be able to put those onto the road and to be able to scale it.
To answer the question though, redi-cycle takes battery shreds and recovers nickel, cobalt, lithium, copper from those shreds. And redi-shred is the service where trucks come on site to where you have your waste, and through a process that involves a blast freeze before shredding into shreds into an aqueous neutralization solution. This renders the material inert and harmless at the end of this process before the truck ever rolls.
So right now I would say with redi-shred, we're really in a technology enhancement and development stage. So what this means is we know that it will work, but we do need to refine it to make sure that we know how much reagents you're using, where do you put all the thermal energy, how much do you need to freeze every single type of battery. There's just a lot of questions that we want to make sure that we're answering before we completely scale this up.
I heard you say the word freeze. Mm-hmm. I've heard the word flame when it comes to battery recycling, because I know that redwood materials, I see molten materials. Mm-hmm. But wait a minute, you guys said freeze. So why are you what are you doing? Yeah, what are you freezing batteries for?
Okay.
I think, Luke, you have a lot of fun things to say about battery shreds. And the reason why we call it battery shreds is a lot of people in the industry call this black mass, but we're really turning it into an inert shred because black mass, as it's defined in the industry today, actually still has thermal potential.
So let's say that I have some battery waste. I'm either on the side of the highway with a crashed EV, or I'm a battery manufacturer, or I'm a battery, one of those cell factories that we keep hearing so much about getting built, $1 million factories getting built left and right.
Yep.
They're going to have some battery waste. They don't know what Fred did with the battery putting together machine. They can't, This is not a usable pack, but they want to get rid of it. They don't want to rip it apart because they're worried. You step in, you say, hi, we're Redivivus. We are going to take care of this. How do you do it?
Well, if they have a cell manufacturing facility, it would be a prime candidate to have an on-site shredder, neutralizer, recycler facility so that you wouldn't need to tie up a mobile truck at a location where it was going to be used all the time. You can just have stationary equipment, which is off the shelf and easier to find, rather than the mobile equipment that we have to work hard to try to duck the 80,000 pound max limit to fit all the gear that we need together. If you want to go through the flowchart process, though, if you have cell waste that you've created and none of them have been damaged, then you have this opportunity where you know that you can ensure to discharge them all. You could even do it with, say, the large aqueous bath solution where you have a mild electrolyte solution and you...
Wait. You said aqueous. That means water. And I learned, if I've learned anything on this channel, it's you don't put lithium batteries in water, Luke. So what are you talking about?
Let's say that you've got, your situation that you described where you've got this cell factory and it's making, if you're going to make, say, 10 million cells a day, even if you have 99.999%, perfect cells that you make, you're still going to have thousands a day that would be fallout in that case if you're making so many, And so in this case, these thousands a day cells, you would be, at a premium for the opportunity to discharge them because they're not protected yet at this early stage. Where battery recycling, so in other words, you could leave them all in a large plastic water trough or whatever for, say, 3 days and then throw them all in a shredding, piece of shredding equipment, and they should have approximately no electrochemical potential energy that they release during that shred period, provided that you don't have a lot of friction and heat buildup during shredding or some other weird problems that can cause issues. But
I think Luke is getting at the discharging prior to shredding versus freezing, because freezing actually costs more money.
That's right. Freezing is what you do if you don't have a bunch of individual cells that would be easy and cheap to discharge, by tossing in a trough of liquid. I guess first he said lithium cells and water, so let's address that. Lithium metal and water, of course, it pulls a hydrogen off of hydrogen hydroxide water, H2O, and it can make enough heat while pulling this covalent bond apart that lithium is extremely electropositive, and so it splits this covalent bond of water and releases a large amount of heat and hydrogen gas, which can ignite the hydrogen and cause little flares and explosions. It also leaves a strong base behind in the water after it does this process. Leaves hydroxides behind when it liberates the hydrogen. So lithium metal is, obnoxious to add to water and behaves poorly in water. But lithium ion cells, it's fortunate that the lithium that is active in the cell is in the form of the lithium hexafluorophosphate ion, in which case that it's captured in a kind of a blanket of 6 fluorine ions with a phosphorus, and it's a complicated reason why, but this helps it solvate through the electrolyte better than it would, and it also, more importantly, there's no metallic source for it in the battery, and so we have the ionization energy when these different salts in the electrolyte dissolve into water, but it's nothing like the energy of, lithium metal splitting water apart in fire.
Okay, so tomorrow, let's say I'm driving my Nissan Leaf and I get into a car accident. It's pretty bad, and the battery, I can see the battery, which I normally can't, so that's not good. Can I call up Redivivus, and what would you do if you arrived on scene with all your equipment? How would you make this problem, which is a fire hazard, how do you make it go away?
Yep. We would need to do whatever it took to separate that pack from the vehicle, and whatever fastener retention there was, or whatever things needed to be cut or pried away to remove that pack from the vehicle. But once that pack was out of the vehicle, let's say all the connectors are broken, the fuse is blown, whatever else has happened from your serious wreck, and let's say that you had just left your driveway fully charged too. This would mean, most processes would have an issue trying to dispose of this battery at this time, and maybe a standard operating procedure might involve someone like a specialist with alligator clips and some resistors, large resistors, clipping to different points, trying to find ways to reduce the amount of stranded energy to a minimum before it would maybe go into water for some extended period, and then at this point could be further disassembled to be shredded. But in our situation, we get to blast freeze your leaf pack right from full, and in a relatively short period of time. It would depend on what model of leaf pack you had. The thicker the batteries are, the longer it takes for the blast freeze, but it's surprisingly fast. And once this pack had reached the appropriate temperature that we knew for your cells would shred tolerantly and allow those shreds to then drop into the neutralization tank, we would stop the blast freezer, and it would be conveyed from the blast freeze chamber into the mouth of the first stage shredder, at which point it drops into the second stage shredder, and those second stage shreds go into the aqueous buffering solution, which will neutralize it into a mixed metal oxide slurry of neutral pH.
Wait, and now you're saying that Jesse's leaf battery, which moments before was a fire hazard, is now just a bunch of materials that are fine to transport?
That's right. It's a bunch of neutral pH aqueous metal oxide shreds.
So wait, you just saved me a lot of money, because before I had to somehow safely transport this 100 miles. Now it's just
that's right.
It's just a truckload of stuff.
And these shreds are not too much different than, say, wet beach sand at the end of this neutralization process from a hazards perspective.
Okay, so now you got this wet beach sand of materials. You bring it back to, say, your redi-cycle plant. Is this have any value? Is there anything good you can get out of this?
There's so much we can get out of these battery materials.
Yep.
And so basically we show up with the redi-shred truck, and we plan to, these are the time and the process things that we're working on right now, where it's like how to have it pre-chilled, how many different stages of shredding, how to mix in the truck and make sure that the conveyance is all there. And so that material essentially gets transported to our redi-cycle process. And from there, we're really focused on getting a nickel cobalt alloy, which we're calling Redivivus nickel. And that's what we plan to sell to the super alloy industry, the stainless steel industry. And we're even working on refining our processes even more as we continue to have those lower parts per million contaminants, as they're called, to open up more markets on where we can sell these materials.
I'm an investor, though. I've heard stuff before where people on paper can do lots of stuff. So you've got patents and you've got this on paper, which is great. But have you actually done it?
Redivivus has done a proof of concept. It has it validated. We have a prototype shredder where we have been doing a lot of our research and development. So we also have some awesome battery clients in the industry that have given us their battery waste. That battery waste has been turned into the beach sand, almost beach sand as we're calling it here. And that beach sand has been turned into Redivivus nickel, which has also been given to metal foundries, which they are now testing and have asked us for even larger samples so they can get those into their supply chain, which is really amazing.
We've already supplied some super alloy makers with samples of our nickel output product from running this process, made from Tesla Model 3 cells, ironically.
So really what that's coming down to on why we're raising money, why we're on Start Engine, is we want to make thousands of pounds of this material, and we want to scale up our shredding abilities, and we want it to be very easy and common, where someone comes and calls, I just got in a car wreck, and we dispatch and you show up on site.
Okay, so one problem I see with recycling batteries is there's a whole bunch of different kinds now. I mean, nickel is very common right now with Tesla, but we're now seeing phosphate batteries. We're seeing lithium iron phosphate. And so there's no nickel in those. So when you get one of those batteries, does that mean there's nothing valuable in it to recycle?
Well, fortunately, our process can still recycle them, and we recover the lithium and the copper out of them, which are both valuable materials. However, when you don't have the high-value cathode materials, that is your dominant profit driver. And so, the process runs and it reclaims materials, so you successfully recycle them. But it will need to be very lean and streamlined to run in a cost positive direction without the nickel.
Is it possible in the future that governments are going to be spending money to help recycling programs? It seems like I'm seeing the governments move in that direction. Whereas
we've never got a penny from the government, but it seems like a lot of other people are getting a bunch of money from the government to do recycling. I don't know. We fund this largely from our own research and development company, which is successful on its own, and so it can help support other things that are still in their infancy to be developed.
I would imagine if I was in the U.S. government's position, they would want to have those elements stay in the country and be reused, especially if they've been imported from other countries.
That's a really good point. You're almost making a mine in the United States when you recover these materials. It's almost like having a nickel mine and a lithium mine right there, a clean one at that.
That's right.
As opposed to having to get it. I mean, most of these materials come from other countries.
That's right.
Right. And I don't know if this story is true, but someone was telling me that the government right now, their strategy is essentially to buy cells from overseas and deep freeze them as their strategy to have batteries long term.
Which was like a strategic resource thing done for military applications or defense applications, to buy Asian batteries and freeze them because there was a lack of parity with U.S. batteries for defense purposes.
And even if that isn't true, I mean, the fact that that's even like a folklore story just shows that there's definitely thoughts when it comes to the government being interested in this type of technology.
Yeah, I mean, I get the feeling that Elon needs materials so badly. I mean, that's what Battery Day seemed to have all been about, was he was talking about like, we need these supplies of materials, and you're talking about how to get them back just the way he needs them pretty much.
Yeah, I'm sure in the future. I mean, I have dreams about riding on Starship and
Me
going
too.
to the moon, going to Mars. I'm all about it. Definitely support that.
Yeah, I mean, we're going to need your process on Mars.
I think
That'd be awesome.
think probably the easiest place to use the material would be Cybertruck's body, because it will be a massive nickel consumer. And I mean, theoretically, there's alloys of stainless which are fairly low nickel and high chromium as a balance, but it depends on what they're going for with strength and temperature performance and other attributes.
And we're talking about a shredding and recycling process with Redivivus that works now. It works 5 years, it works 10 years in the future, but I can only just imagine 10 years in the future, with the amount of lasers that we play with the amount of other technology we have. I just am really excited to see where this goes when it comes to being a commodity supplier and having our hands in our business in that industry where we get to provide companies doing really cool things with the materials they need.
All right, so let's talk about your Start Engine crowdfunding right now. So there's a bunch of ways a startup company can get some funding. You've already had a seed one round for about $200,000 where we weren't, or I think it was $250,000 where, investors like Jesse and I couldn't get in on that, and a lot of you watching today couldn't get in on that. But this is a crowdfund round where you can get in on it, and that is on the Start Engine platform. And so basically you file with the SEC, you tell them what you want to do, you tell them that in this case, this is a pre-money valuation of $20.7 million, $2.25 a share, and there's about, I think, a $250 minimum for investors out there. And you're looking to raise up to $1 million on this round. I think already, as of the recording of today's show, you've raised over $300,000. It probably is more by the time you're watching. So if I'm watching right now and I'm interested in this, first of all, where can I go to find out more information?
We are startengine.com/Redivivus, where we have put our processes out there, and we do regular updates as far as who we're talking to and what we're doing, so you can stay in touch with us.
Now, this isn't going to be forever. This round's going to close at some point. Do you know when it's going to close?
I know that it is allowed to be open up to 180 days, and we launch sometime late November.
Okay, and so then I think anyone getting in on this round wants to know, when are you going to IPO? When can I? Yeah,
I'm going to make it big if you IPO. So when's that going to happen?
Just tell me exactly when that's going to be, and I can plan that into my
then I can buy my
schedule.
Island. Yeah.
Yes.
That's so good. I really love this community, and I really love the opportunity to grow it and find support. And I really have been enjoying talking with different people as far as what questions do we need to answer to make sure that we're putting the right message out there, to make sure that we're being clear enough. And we get the question on when are we going to IPO, probably once a day even. I want to make sure that we feel comfortable in where we are. I want to make sure that we are in the right spot. To me, it sounds not reasonable to go IPO 2 years into a startup.
I think if you could do it privately, why would you ever go public if you could do it privately? You know?
Right. I mean, that's what Elon says all the time, and that's why he hasn't gone public with SpaceX yet, right? Because, I mean, why have public shares? Why have to do all these SEC filings if it's a private company? And it is kind of a ridiculous question because you don't know the answer. I mean, no one knows at the beginning of a company how long that journey will take. It could take 10 years. It could take 20. It could never happen. So
that's right.
For the investors watching, though, they're like, okay, but that's the only way I know how to trade my shares is if you go public. And that's right. It's a little bit weird. If you trade in, say, Tesla shares, they're on a market every day. You can track them up and down. But these shares, they still will be shares in a company, but they're not publicly traded. So it's harder to trade your shares. And so for a lot of investors, that's why they stay away. But I do want to point out again, small company could become a big company. If you were one of the first, investors in, say, Tesla, you'd be pretty glad you were one of those investors. So it's just something to think about. We're not financial advisors. Don't take our advice as financial advice. We're just two guys on the internet. Do your own research. But this is a way, a lot of people always say, like, how do the rich people always get rich? How do they know people?
It's because normally you wouldn't have ever heard about this funding round. Right. This funding round would have been going to VCs.
Yes.
It would have been yucking it up at some country club. Yep. It would have been like, well, you should really think about it. This is where most of the money gets made in a lot of companies. If you were to buy Tesla tomorrow for somehow under $1,000, which is amazing, and then the next week it goes up to $1,200 and you sell, you're still not making anywhere close to the return of the people who invested much, much earlier, way before you could invest, before it was on any market.
Right, because keep in mind, if you invested the first day of the public trading of Tesla, you'd be up 200x today. But if you invested earlier than that, and you're like, how could you? Well, that would have been before they went public. You would be making way more than 200x.
And so I want to thank you guys for opening it up to crowdfunding so early, because it does give people the opportunity to get in on this, especially for people who believe in this and they just want to diversify their portfolio a little bit more and not say like, well, I'm invested in Tesla because I believe in the electric revolution and I could, that's tough. What else do I really invest in if I really believe this? So I think that this is a great way for people to get in almost at the ground floor.
Now, you did mention earlier you have partners, and one of the partners I know you guys are working with, and this is public information, is Arcimoto, one of our friends, Mark Frohnmeyer, the CEO and founder of Arcimoto. Can you tell us at all anything that you're doing with them?
I don't know what we can tell other than I think it's public knowledge that we help with powertrain development. We do research and development to help many different clients with powertrain problems, specializing in corrosion, vibration mitigation, efficiency improvements, thermal management improvements, and
we get in our research and development company, we get to work on a lot of fun projects, and Mark has been a longtime friend, and he asked us to come and help us develop his new platform, his new dream, new technology. And the partnership with Redivivus actually allowed us to not only work from the cell level all the way up through building new modules to testing them, basically murdering them, and then giving them a new life. So those modules that we've worked with Arcimoto have been responsibly recycled and turned into the base elements that we're working on at Redivivus.
Yep. Which is cool to see packs go full circle from idea, conception, build, test and validation, and then recycling the test and validation packs all in the same loop. It's been awesome to see. Look forward to many more developments.
Now, speaking of full circle, if I'm a European company, a lot of European companies are mandated by law that they have to account for what's going to happen to their products once they go into the waste stream. I know as Americans, we don't care. We just throw them away. But if I'm a European OEM making cars, I would think that I would want to start talking to someone like you, because I'm going to need you guys at Redivivus, because I'm going to need to come up with a plan for what to do with that car once the customer comes back to me and says, hey, my car's dead. We need to recycle it.
Yep.
Absolutely. We've gotten a lot of great feedback actually from European OEMs and talking to them about our ideas. And, you know, some people might think that we're crazy for wanting to make sure that we can shred charged batteries. But realistically, in the real world, just like people are starting to understand what happens to a battery in the real world, I feel, have a realistic perspective on what needs to happen in the recycling industry to do it as well. And it's been awesome to talk to different people and say, you guys have a great idea and let's work together. And a lot of those conversations have been optimistic, made me super optimistic about the future.
Now, what are some next steps for Redivivus once this funding round ends, and what will the money be and the funding be used for?
Developing the mobile shredding rig, which, currently we do stationary shredding, and having the first ability to do mobile shredding lets us leverage the redi-shred resource for the first time.
I would like to say on Start Engine, you can go and you can read. We had to say exactly what we would allocate the money for, so you can see that. But it really is just scaling our efforts, reducing costs, making sure we're making the right technical decisions, having that R&D, and showing up with a truck right after that.
Well, I think, if possible, one of the first tests should be Jesse's Leaf, because it sounds like it ain't coming back from that Nissan dealership, dude. I'm sorry to tell you.
It's been there for about 2 months, and
oh man,
waiting for the batteries.
It may be ready to go into a redi-shred.
No, I think they're gonna fix it.
Okay.
It's just how am I gonna be driving it after? You're going
to be driving at like 30 miles an hour. It's going to be in limp mode.
It was in limp mode when I brought it in. Geesh. But yeah,
turtle mode.
Yeah, turtle mode. It was.
Luke had a Leaf back in the day too.
Yep. I've had a Leaf. I had a Corbin Sparrow. I had a Gen 1 RAV4 EV, a 2000 Toyota RAV4 EV. I've had all the low performance vehicles.
And just a fun fact, if you guys are looking for some fun YouTube videos, if you want to go down a rabbit hole, go find Luke's YouTube channel from about, 10 years ago, when, boy, he did everything he could think of to battery cells.
Everything from stabbing them with nails, screwdrivers. I think you shot an arrow at one point. I was just watching it. It was in fascination. I'd never seen lithium-ion cells being treated with such disrespect. But it's given you it must have given you such an interesting perspective on batteries. I don't think that any of us have really even seen what happens when a battery gets mistreated and what happens to it. So, when we're talking about shredding a battery and doing it safely, I'm so glad that it's you doing it and not someone who's just sitting up in their office all day.
Well, thank you, my friend. When I made a lot of those videos 10 years ago or more, I was doing it as a hobby, just out of love for experimentation with batteries. But batteries used to have much higher fractions cobalt, and because of this, they were much calmer during thermal runaway, and the temperatures it took to induce thermal runaway were higher, and the amount of mechanical damage it took to induce thermal runaway was higher. And modern batteries that push the highest nickel fractions in their cathodes,
including silicon anodes.
And the higher fraction silicon anodes in the, as well. These things break down with less mechanical stress than ever, from mechanical damage, and lower thermal values than ever to initiate runaway as well. And so, some of the things in my videos from 10 years ago, I don't know if I would want to recreate those with modern cells today. Modern cells are packing something like 2 times the energy, or maybe 50% more energy than they were 10 years ago. But they've also, different behaviors when abused. So your results may vary if you try duplicating any of those tests.
Right. We have gotten a lot fancier when it comes to the battery testing disrespect. But there's a lot of things that, we can't share, but they're definitely ingrained in our brains. So we know it's out there.
Yeah, we do a lot of abuse testing, including thermal runaway calorimeter testing for clients where we fail their cell in a calorimeter and we quantify the joules of energy released, the gas pulse released, and can do gas species sampling. And this helps clients refine mixtures to be the most gentle in energetic releases during thermal runaway. And so this is one of the ways that we help climb back to safe with today's cells to be as safe as they used to be. You know, it's an interesting mix though, because 10 years ago you had legitimate manufacturing defect issues in cells, but the cell materials themselves made pretty safe cells. And today you have incredibly high quality and high precision and highly uniform cell manufacturing with minimal margin in cell and cathode stability compared to the old material. So it's a different, you know, you're trading which devils you're dancing with, from manufacturing issue devils to energy density induced lower stability, lower thermal stability.
All things that we've had to take into account when designing and building the redi-shred concept.
Well, Erika and Luke, thank you so much. It's always so fun and so educational to talk to you. I'm so excited about the future of Redivivus. I'm so excited to be a shareholder, and I can't wait to hear updates in the future as to what's going on. So thank you for joining us today.
Thank you.
Thanks for having us.